So good evening to one and all. My name is Arul Sulam, the Assistant Professor CSE from Hindustan College of Engineering and Technology. Now I am going to present a video about Huffman coding in design and analysis of algorithms. So now first we will see the basic definitions of Huffman coding. Huffman coding is a technique of compressing data to reduce its size without losing any of the details. It was first developed by David Huffman. Huffman coding is generally useful to compress the data in which there are frequently occurring characters. So now we'll see how Huffman coding works. Suppose the string below is to be sent over a network. So each character occupies 8 bits we know. There are a total of 15 characters in the above string. So thus a total of 8 into 15 that is equal to 120 bits are required to send this string. Using the Huffman coding technique, we can compress the string to a smaller size. Huffman coding first creates a tree using the frequencies of the character and then generates code for each character. Once the code is encoded, it has to be decoded. Decoding is done using the same tree. Huffman coding prevents any ambiguity in the decoding process using the concept of prefix code. That is, a code associated with a character should not be present in the prefix of any other code. So Huffman coding is done with the help of the following steps. First step is calculate the frequency of each character in the string. So for example, here B occurs 1 time, C occurs 6 times, A occurs 5 times, and then D occurs 3 times. Second step, sort the characters in increasing order of the frequency. These are stored in a priority queue. For example, it is stored in a sorted order 1, 3, 5, 6. That is B, D, A, C. The characters are. And the third step is make each unique character as a leaf node. Fourth step, create an empty node Z, assign the minimum frequency to the left child of Z, and assign the second minimum frequency to the right child of Z. Set the value of the size Z as the sum of the above two minimum frequencies. For example, here the first two minimum frequencies are 1 and 3, that is B and D, the characters. So like this we are merging it. 1 and 3 are merged together and the internal node forms the total is 4. So it is denoted as star. That is the fifth step. Remove these two minimum frequencies from Q and add the sum into the list of frequencies. Star denote the internal nodes in the figure above shown. Sixth step, insert node Z into the tree. Here node Z is nothing but it is a star. Seventh step, repeat steps 3 to 5 for all the characters. So after repeating step 3 to 5, we'll get these trees. For example, here the node 4, internal node 4 and the leaf node 5 is merged and the new internal node forms it is 9. And after that, the internal node 9 and the character node C, it is merged and the new internal node forms it is sum is 15. So 8th step, for each non-leaf node, assign 0 to the left edge and 1 to the right edge. So it is shown in the figure. For sending the above string over a network, we have to send the tree as well as the above compressed code. The total size is given by the table below. For example, we know that the characters here are A, B, C, D and the frequencies are 5, 1, 6, 3 and the code forms from the tree is 11, 100, 0 and 101. And the size is the number of frequencies into the number of digits in the code. So we'll get 5 into 2 that is equal to 10, same as like 1 into 3 equal to 3 and then 6 into 1 equal to 6, 3 into 3 equal to 3. So here the total bits required to send this over a network is 4 into 8, that is the 32 bits, and then frequency for frequency it requires 15 bits and the total size it requires 28 bits. So without encoding, the total size of the string was 120 bits. After encoding, the size is reduced to 32 plus 15 plus 28, that is equal to 75. Next one is decoding the code. For decoding the code, we can take the code and traverse to the tree to find the character. For example, let 101 is to be decoded, we can traverse from root as in the figure below. So from root, the 1 is that is from node 15 to 9 and for 0 we have to traverse from node 9 to 4 and for again 1 we have to traverse from the node 4 to 3 and finally the decoding character is D here. Thank you.